All right, this is intermediate algebra, section 1.5, which is functions. Starts on page 43 of your book. All right, the first thing we see on page 43 is the definition of a function. A function is a special kind of relation that has exactly one y value for every x value. All right, that's the definition of a function. You've seen examples of functions before. Y equals 2x plus 1/7. This is y equals mx plus b, a linear equation. In function notation, f of x equals 2x plus 1/7. This is actually the same function in function notation, where this is just the name of a function. This does not mean f times x. We read this as f of x. Just replaces y. It's just the name of a function. And there are other types of functions, many different kinds of functions. We're going to look at graphically how to determine whether a relation is actually a function. All right, example 1 on page 44 gives us this relation. It's a set of ordered pairs, 3 ordered pairs here, and asks us to determine if this is a function or not. All relations are not necessarily functions. To do that, there's an interesting graphic here that basically lists the x values and shows how they match up with the y values. So the x values here, or the range, the domain is -7, -6, -5. The range, or the y values, are 49, 36, and 25. Now, how do they match up? Does every x value have exactly one y? Well, this one matches up to this. We can see that here in this ordered pair. This one matches up to this, and this one matches up to this. The definition of a function is exactly one y value for every x value. So you can see there's one y value for every x value. So is this relation a function? Yes, this is a function. And that's how you answer that question. Okay, for example 2, we have a new relation, and we're being asked to determine if this is a function or not. So we're going to do the same thing. We're going to make a little graphic here with all the x values and see how they match up with the y values. The domain, the x values are the domain, -4, 0, 1, and 2. So we'll list them here. And the y values, the range, 9, 4, 4, and 5. That's a -9. We don't need to list the 4 twice, just like before. Now, how do they match up? -4 matches up to -9. 0 matches up to 4. 1 also matches up to 4. And 2 matches up to 5. All right, the definition of a function is there's exactly one y value for every x value. So this looks a little weird here, but does every x have exactly one y? Yes, every x has one y. It's okay that 2 different x's are sharing a y as long as each x has only one y. So yes, this is a function. Every x has one y. It's okay if 2 x's share a y as long as each one has only one y. Okay, for example 3, we have a new relation, and we're being asked to determine if this is a function. So we're going to do the same thing again. We're going to list the x values here, the domain, and we're going to see how they match up with the y values over here, the range. So the x values are 0, 1, 3, 3. And we won't list the 3 twice. So 0, 1, and 3. The range, 4, 6, 8, and 10. Those are all different. 4, 6, 8, and 10. Now, how do they match up? 0 matches up to 4, 1 matches up to 6, 3 matches up to 8, 3 also matches up to 10. The definition of a function is every x value has exactly one y value. Well, this is a problem here because this x is being mapped to two different y's. This is a case where this is not a function because every x can have only one y, exactly one y. So when an x is being mapped to two different y's, it's a relation that is not depicting a function. Okay, example 4 is on page 45. We're going to determine if this graph is a relation just by looking at the graph. Okay, this is actually easier than you would think because there's this rule called the vertical line test, which says if I can draw a vertical line any place on my graph and it only cuts through the graph in one place, then it is a function. A vertical line will only cut through a graph in one place if it is a function. If it cuts through the graph in more than one place, then it is not a function. And I don't know if you guys can see what I was just doing with the pointer, but if I draw a vertical line right here, it cuts through this graph in two different places. Same thing if I draw it here. Okay? If a vertical line cuts through the graph in more than one place, then it is not a function. So this is not a function. Okay, example 5 on that same page, page 45, looks like this, and we're being asked to determine if this graph is the graph of a function. And again, the vertical line test says I can draw a vertical line through a function and it will only hit the function in one place or pass through the graph in one place. If you draw multiple vertical lines here, it doesn't matter which vertical line I draw, it only cuts through the graph in one place. Okay, that's the vertical line test. A vertical line will only cut through a function in one place. So yes, this is a function. Okay, I know you guys are going to laugh at my drawing, but this is the graph that you can see at the top of page 46. It's the graph of a circle, and we're being asked to determine if this is a function. When you're being asked to determine a function from a graph, you use the vertical line test. If a vertical line cuts through your graph in more than one place, which is the case here, you see these lines cutting through the graph in two places, it's not a function. So just to reiterate, using the vertical line test means you can draw a vertical line any place on the graph of a function and it will only cut through the graph in one place. If a vertical line cuts through a graph in more than one place, then it's not a function. Starting with example 7, we're going to do something called evaluate. We're going to evaluate a function. Now we're being given this function, which we read w of x equals negative 9x plus 4. Find w of negative 2. What that means is that we're going to replace x with negative 2 in the function. We are not going to change the name of the function. This w of x will get changed to w of negative 2. And this is what it looks like when you substitute it in. W of negative 2 equals negative 9, and we're replacing x with negative 2. So negative 9 times negative 2 plus 4. Now, there is no operation here. This is just the name of the function. All the operations are over here on the right, and then we just use order of operations and simplify all this. So that turns into Negative 9 times negative 2 is positive 18, plus 4 is 22. That means W of negative 2 equals 22. This really is an ordered pair here, guys. So what this really means is that on the graph of this function, this is actually the function of a straight line. When x is negative 2, or when I replace x with negative 2, y comes out to be 22. And that would be an ordered pair or a point on the graph of this function. This is just showing a little bit of understanding that we're talking about a graph, we're talking about a function, and this point would be on the graph of that function. When x equals negative 2, y equals 22. Or in other words, when I substitute negative 2 for x, it simplifies out to make 22. This ordered pair would be on the graph of that function. In my class, telling me this ordered pair gets you some extra credit. Okay, at the top of page 47, we'll see example 8, which says, given the function p of x equals negative 9x squared plus 3x minus 4, find p of negative 3, which again means we're just going to substitute negative 3 for x. So we'll put it in here like this. P of negative 3 will equal negative 9 times negative 3 squared plus 3 times negative 3 minus 4. And we're going to use order of operations here. This can be a problem for some students. Remember, in order of operations, we work exponents first before multiply. So do not multiply negative 9 times negative 3 and then square it. Square the negative 3 first, then times negative 9, and yes, it does make a difference. So when we square negative 3, we get positive 9. Negative times negative makes positive. And then we're going to go down to the next step, which is the multiply. So this will make negative 81. This makes negative 9, 3 times negative 3, and this makes negative 4. And then when I add all those numbers together, they're all negative, we get negative 94. So P of negative 3 equals negative 94, which in an ordered pair means that when x equals negative 3, y equals negative 94. Okay, example 9, we're given the function r of x equals 5x minus 4, and being asked to find r of 1/5. Okay, I know half of you guys are freaking out about this 1/5 right now. It's okay. If you have trouble with fractions, you just need to practice them a little bit more. We're going to put the 1/5 in for x, or substitute it in. So that looks like this. R of 1/5 equals 5 times 1/5 minus 4. Remember, there is no operation over here on the left. This is just the name of the function stating that we're replacing x with 1/5. All the operations are on the right. Okay? We're not trying to solve for r. We're just trying to find what does y equal when x is 1/5. Okay, here you have 5 times 1/5, which I hope you guys recognize. They're reciprocals, 5 and 1/5, and whenever you multiply reciprocals together, you get 1. So this is 1 minus 4, which is negative 3. R of 1/5 equals negative 3. In an ordered pair, that means when x is 1/5, y is negative 3. Okay, example 10, still on page 47. We're given the function r of x equals 5x plus 3. Find r of 1/4. Again, we're going to substitute 1/4 for x. So we're finding r of 1/4. That would be 5 times 1/4 plus 3. There are no operations on the left. Just use order of operations on the right. When you multiply 5 times 1/4, you get 5/4, and 5/4 plus 3 is 3 and 5/4, but we're not going to use a mixed number. We're going to change it to an improper fraction. Multiply, then add. 12 plus 5 is 17. Use the same denominator. So this becomes 17 over 4. So r of 1/4 equals 17/4. In an ordered pair, that means when x is 1/4, y is 17/4. Okay, so example 11 is pretty interesting. You're probably really going to want to go to page 48 because I tried to reproduce it here. My drawing is really not that great, but we have this function here with some points mapped out on the function, and we're going to answer the questions about this graph. The first question being, find, this is A, find f of 2. This means that when x is 2, find the y value that corresponds to that. So we're going to follow the x-axis to 2. We're going to find a point on my function that has an x-coordinate of 2. All of these points that line up vertically here have an x-coordinate of 2. This is the one that's on my function that has an x-coordinate of 2 because it lines up with the 2 here. The y value here is 4. This is the point 2, 4 right here. Okay, so f of 2 equals 4. All right, letter B asked us to find f of -2. So we're going to do the same thing. When x is -2, what y value goes with that? So we're going to follow the graph. This is x -2. This is the point right here that has an x-coordinate of -2. Its y-coordinate is +2. So f of -2 equals +2. Letter C, ask us to find the values of x. Find x when f of x is -1. So in other words, they're asking us to find x this time, not y. F of x is -1. In other words, f of x equals -1 or y is equal to -1. If we're finding x, they're telling us y. So this time we're going to follow the y-axis down to -1. And we're going to see, actually, I did not put this point in the correct place because this is the point that should be here. It should be further up here, right where the number 5 is. Okay, if you look in your book, you'll see that. This is the point that has a y value of -1, and it lines up with x equals 5. So when x equals 5, f of x equals -1. And you could answer this as an ordered pair even. 5, -1. All right, we have letter D here, so I'm just going to scroll up a little bit here. Find the values of x. So again, we're finding x when f of x equals 0. So if we know f of x, we know y, and we're finding x. So we're going to follow where the y value of 0 is right here at the origin. There are actually 2 points on my function that have a y value of 0, and that's fine. It's okay if 2 different x's share the same y, remember? So x equals, what are these x values here? 1, 2, 3, 4. This would be -5, and this would be +4. Okay, and it does say find both values, so that would be your answer there. All right, I'm going to cut this section right here because it feels like this is getting kind of long and there's still quite a few examples, so look for part B for section 1.5.